Discrete, Chapter 6, Section 1, a counting activity. You'll find that counting is a necessary evil, and it's not perhaps as easy as we try to make it out to be. So first of all, let's read a description of something here. The members of Central High School, the Student Council, are debating fundraising activities for the organization. One of the proposals they have is from Pierre. He suggested that the group operate a game involving the school's team name, the Lions. At the annual school fair, his idea is to write each of the letters of the word on a ping pong ball and to allow students to draw two of them from an opaque container. If the two letters drawn spell in order a legal word, the participant will win a prize. His plan has been criticized by the other members who feel it would be too easy to win. Well, with that in mind, if we go and try to analyze some of that, the exercise is on page 269. First of all, it says, make a list of all possible words of two letters that can be made from the word lions. And how many different words are there? And it may depend upon how you do this, I guess, a little bit. But if you take the word lions, this is number one, and you pull two at a time, you can get an L-I, an L-O, an L-N, and an L-S. If you do this sort of in order, then you can get an I-O, an I-N, and an I-S. Then you could get an O-N, and then an O-S. And then you could get the N-S. Now, if that's all you choose, those are the ones in that order. But we could get perhaps the opposite order for those two when you pull them. The L-I could have been an I-L. The L-O could be O-L, and then N-L, and then S-L. The O-I-N-I, S-I, N-O, S-O, and S-N. So all of those are the possibilities. How many are there? See, 8 and 6 is 14, and 4 is 18. There's 20 possible ways, right? And the question is there perhaps a better way of figuring this out? We'll get to that. That's problem number one. Number two says, suppose the ping pong balls are drawn one at a time. How many different ping pong balls can be drawn on the first draw? Well, what they're really asking is, when you draw the first one, how many different ones you might pull out, since there are 1, 2, 3, 4, 5 different letters. There are 5 ways of drawing that first one. Now you don't put that one back in, you draw the next one, so there are only 4 different ways of drawing the next one. What do you get when you multiply those together? 20. Same as that. This is called the fundamental rule of counting. If there are m ways of doing one activity and then n ways of doing the next one, the number of ways of doing both is m times n. In this case, 5 times 4. So what about problem number 3? Let's see, I'm sorry, we're still have to do number 2 a little bit. They say, now let's look at it, maybe somebody else's team, which is tigers. So if you look at the tigers, this is part A. Part B is tigers. Now there are 6 ways to choose the first one, and 5 ways of choosing the second one. You get 30 possible ways of choosing 2 letters. So this is how you could figure out, because of the fundamental rule of counting, how you do some of these things. The next question maybe is, okay. Suppose, though, that you have duplicates, like, I don't know, Mississippi. Well, what we'll find is if you choose all of these, right now we just choose 2 of those, right? If you choose all of these, there are 6 factorial ways of doing all 6 of those in any order, doing all the different orders. And you remember what factorial means? It's 6 times 5 times 4 times 3 times 2 times 1. Or whatever you take, the number of letters, you count down and multiply as you go. This is quite a bit. We had, if you go from right to left, this is 6 times 4, which is 24, times 5, which is not quite 100, it's 96, right? 24 times 5, I'm sorry, it's not 96, it's 90. Hold it. 24 times 5, that's 120. I'm sorry. I knew that had a 0 on the end. And then times 6, oh my gosh, 720 ways. So 5 factorial is 120. That gets up there quick. 6 factorial, 720. These numbers get large very quickly. So if you would take all 6 letters, and if they're all different, then you use factorial. We only took 2 at a time. There's another rule for that. The fundamental rule is one of those. But suppose you have duplications. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 factorial, which is big. I don't want to figure that out. But the duplications, we wouldn't notice if we put this S first and that S second, or vice versa. So every time you have a duplication, you have to get rid of those factorials out of it. So there are how many i's? 1, 2, 3, 4. So you divide by 4 factorial to get rid of the i's. How many s's? 1, 2, 3, 4 s's. You get rid of all those. How many p's? There's 2 p's. Get rid of all those. Now you can use this, I guess, with tigers. You just have to remember, what is 1 factorial? Well, that is just 1. What is 0 factorial? This may be strange. There's also 1. So if we would use this sort of general process, all of these would be 1 factorials, and you get that 6 factorial over a bunch of 1 factorials, which is just 1. To get rid of the duplicates, you divide by the number of duplicates factorial. Now, can you cancel things? Yes and no. 11 becomes 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial. One of those 4 factorials can be canceled with that, but you can only cancel factorials. The other factorial, 4 times 2 times 3, 4 times 3 times 2 times 1, and the 2 times 1, you have to do that, I guess, individually. 2 goes once and 3 times. Here's a 3, and that's once, and a 3. This 2 will go into 8 4 times. So the denominator is now all 1s. The numerator is 11 times 10 times 9 times 4 times 7 times 3 times 5. Gosh, is there a way to do this on your calculator? Why, there sure is. Well, I hope you can see this well enough, but to get 11 factorial, you put in the 11, then you go to Math, Num, and you can see, gosh, Prob rather than Num, and go down to number 4, which is the exclamation point factorial. If we press enter, we get a big number for that. Let's get that back, second enter. We want to divide that by these others. Now we better put parentheses because not these would have to be all in the denominator, and I can't do that right now. So it's 4 math prob 4 to get the factorial. Another 4 math prob factorial, and a 2 math prob factorial. Close the parentheses. 34,650. Let's see if we would have gotten that if we would have just multiplied these over here. 11 times 10 times 9 times 4 times 7 times 3 times 5. Ah, what did I do wrong? Let's see. Oh, I never got rid of this 4 factorial. Excuse me. This doesn't all become 1. That was a 4. So this 4 cancels that 4. So now let's try and see. So it's 11 times 10 times 9 times 7 times 3 times 5. Ah, what else did I miss? Three and the 3, oh, there's no 3 there. Gosh. 11 times 10 times 9 times 7 times 5. Whew. So, now why did I leave this on the tape? Because you should learn to use your factorials like this and not try to cancel and do this. Although that you should know that this is available. It's easy to make some simple mistakes. Use your calculator to find this stuff. It'll do it for you.